Hey there, here we go into another awesome video, an introduction into polar, points and graphing. And we're going to start out with a very important piece in this video. You're going to be using these conversions a lot. How to convert from rectangular form, that's x comma y coordinates, to polar form, r comma theta. So I'll just kind of put that up here so you have that there, x comma y to r comma theta form. And vice versa, going from r comma theta form, polar, back to rectangular form. So what's the importance in all of this? And I'll just draw arrows here. You're going to be using this a lot as we get into the calculus of things, especially these, because it allows us to do what's called parameterize a curve. More on that a little bit later. For now, let's just work on conversions. So I'm going to explain why these conversions make sense. So you've got x squared plus y squared equals r squared. And you could take that further and say that r is therefore equal to the square root of x squared plus y squared. Why does that make sense? Well, if you have a point, whether it's represented in rectangular or polar form, it makes sense because this would be x and that would be y. And x squared plus y squared would give me r squared. It's the Pythagorean theorem. Take a square root of that and that gives you r. Why does tangent theta equal y over x? Well, because looking at this, y over x is quite literally the opposite of theta over the adjacent to theta. And so that gives us our value there. Coincidentally, it's also the slope of that line too. More on that later. Now, the other conversions, this would be if you're given r and theta and you want to go to rectangular, you want to get x and y. This was to find r and theta from x and y. So now here, this makes sense because if you look at this, we have that x over r is adjacent over hypotenuse. And that is equal to cosine of theta. Going one more step then, solving for x, that's r cosine theta is x. Then, solving for y, we'd have y over r is equal to the opposite over the hypotenuse, which is sine of theta. So y is equal to r sine of theta. And so now from here, I'm able to then say, oh, that's why those conversions work. Know these formulas, especially these two. Know those two, but know these two especially. You'll be in great shape. All right, let's keep rocking and rolling here. So, convert each of the following into rectangular coordinates. So we want to go from r comma theta to x, y. How do we do that? We use our conversion. So that's x equals r cosine theta, y equals r sine theta, and that'll give us our x, y values. So I've kind of given just graphs just to see why these points make a lot of sense here. But really what I want to do is just get you really comfortable with the conversions. So here the x coordinate is going to be equal to r, which is 1, cosine of pi over 4, which is equal to 1 times root 2 over 2. So that's root 2 over 2. So that's my x value. Y is going to be equal to 1 times sine of pi over 4. And that's going to be equal to 1 times root 2 over 2, which is root 2 over 2. Therefore, this converts to a root 2 over 2. That's your x value. It's not bad, just plugging and chugging, comma root 2 over 2. Nice. Now, why does this make sense? Well, if we rotate pi over 4, we're somewhere right here, and we go out 1, that's right about there. And if we think about it, that makes sense. That's root 2 over 2, root 2 over 2, right in the middle. Very nice. Okay, now, negative 2 pi over 3. Well, okay, let's actually graph that one out first, just for giggles. So negative 2 comma pi over 3 is going to be, well, we rotate pi over 3, but then go in the opposite direction, down here. Right? Because we'd rotate to pi over 3 roughly there, and then go in the opposite of that direction, the negative direction, which would be the opposite of pi over 3. Now, we're going to use the same conversions. That would be r cosine of pi over 3. That's going to be our x value. And that's equal to negative 2 times cosine of pi over 3 is positive 1/2, which is equal to negative 1. Sure enough, we're left 1 there. It's pretty sweet. And then y is equal to r sine of pi over 3, just using this. And so that's going to be negative 2 times root 3 over 2, which is equal to negative root 3. Sure enough, we're to the left 1, down root 3, so to the left, and then down more than we are over, which is exactly where that point is. So our point is going to be negative 1, negative root 3. And that's it. That is how you convert from polar to rectangular. Use x equals r cosine, y equals r sine. That's not the last time you've seen those functions. We're going to use them a lot as we get into the derivatives of polar equations. Oh, it's beautiful. We'll get there in good time. Convert each of the following into polar coordinates. So these are in rectangular form. So this is x and that's y. This is x and that's y. And we're going to go the other way now. So those equations we're going to use, we're going to need r. Remember that r is found by taking the square root of x squared plus y squared. And theta is found by essentially doing the tangent inverse of well, actually not quite. You know what? I'm going to back off of the tangent inverse. I'll show you why in a second, because it depends where the point is. We know tangent inverse, bit restricted. If you forget that, go back to chapter 5. I go over tangent inverses and sine inverses way back there. We'll say that tangent theta is equal to just y over x. So those are our two formulas we're going to institute here. Let's plot out the point. 3, -3 is right 3, down 3, roughly there. Okay, so now to find r is equal to the square root of x squared, which is 9, 3 squared, plus -3 squared, which is also 9. And that simplifies down to root 18, which is the same as 3 root 2. So that's our r value, That's a lot of r's. And then theta, how are we going to get there? Well, I know that the tangent of theta is equal to -3, or y, over x, which is equal to -1. Now that's down here. There's a couple different ways we could represent that. Remember, there's multitude of ways we could represent it. So -1, that could be 7 pi over 4. That could be -pi over 4. So that's why I don't just say, hey, use tangent inverse, because that restricts you to one value, though. If you have a calculator, guess you could. We're in the fourth quadrant there, -pi over 4, 3 root 2. So my r value, and -pi over 4. And I like to graph it out and say, oh yeah, that makes sense, because our point was down there, and this would be rotating -pi over 4 and out 3 root 2 in the positive direction of -pi over 4. You might be like, the positive direction of -pi over 4, the positive r direction. We were going in pi over 4, -pi over 4, and we stayed that way. All right, let's keep rocking and rolling here. We've got -1 comma root 3. So that's going to be left 1 up root 3 like this. And so now, again, I'm going to use my conversion. So r is equal to the square root of -1 squared plus a root 3 squared. It's actually going to work out decently well. -1 squared is 1. Root 3 squared is 3. That's going to be the square root of 4, which is, ooh, nice. It's 2. And then theta, we're going to find that by saying the tangent of theta is equal to root 3 over -1. Now this one's a little tougher to do mentally, but we can handle it. This is the same as saying, where is sine theta over cosine theta equal to root 3 over -1? Well, that'd be the same as root 3 over 2 over -1/2. Looking at the graph, I know that cosine, which is in the x direction, is negative, and sine, which is in the y direction, is positive. That's how I get that. The theta value that occurs there is going to be at theta equals 2 pi over 3. And that, again, is knowing your unit circle, which you've got to know. If you don't know that now, you better be studying it for this chapter. It's muy importante, very important. All right, so now r comma theta will be 2 comma 2 pi over 3, which makes sense because we're going to rotate to 2 pi over 3. That's roughly where the point is, and then extend out 2. All right, so that's it. We're going to go over some exercises now. Just practice this stuff. Get really, really strong at it. I'll see you there. Peace.